Hello, I know I said I wasn't going to make any more videos about this CNC thing, but it occurred to me that people would probably be interested to know how did all that carbon fibre cutting go over time, and also what was happening with that problem that I had with the interference from the spindle turning off or getting in between the Arduino and the computer. So as far as the interference problem goes, at this point I can say it's working very, very well with Bluetooth. I have not had even one single disconnect between the Arduino and the laptop since I started using Bluetooth, so I'm really, really happy about that, because I did some quite long jobs with the carbon fibre and managed to run it for 2 jobs that were 2 hours each without any trouble. Well, I broke an end mill, but apart from that, no trouble. And I also thought I might just have a look at this brushless spindle that arrived, although now I have to admit I'm probably not going to use this for a while at least. I don't think I need to replace the brushed spindle that I'm using now that the Bluetooth has solved the problem. But just in case somebody's interested in what this is like, I just got it now. I just took everything out of the box and I'm about to spin it up and see how it works. But this is a, say on there? Yeah. This one is a brushless, of course, motor, and it goes up to 50 volts. So in order to run this, I had to buy another power supply, which is what this is. This is a mains voltage, 220 volts down to, I think this one goes up to 48 volts, which is probably going to be just about right. And it has a nice little LED display on there, and you can adjust the voltage with this dial, so hopefully that would be pretty good. The controller here, wasn't too impressed to see that it has a big dent in it when I got it. And it looks like some of those pins there are actually a little bit bent too. And you can see something's whacked into it from the top, and it's got a gouge on the sides here. Sort of wonder if this whole thing might have actually been used in the past, like maybe it's not a brand new item. Yeah, so that's a little bit annoying, but over here we can see there's a few pins that come connected with just a switch and a potentiometer on there to adjust the speed. You can do other things with this too. It's all running at 10 volts though, as you can see on this one here, so the logic level is a little bit inconvenient if you want to try and control this from your Arduino, although I think, to be honest, I'm just going to run this manually, turn it off and on myself, and just keep the Arduino completely disconnected from all of this stuff just to be safe. And the motor is over here. It's actually quite short in this direction, the vertical, whatever you call this, length of it, and it's a little bit more, a little bit wider diameter. It's a 57mm one, at least this silver part here is 57mm there. So unfortunately it's not going to fit in my 52mm spindle clamp that I've been using. And that was kind of annoying, because I know what a gamble it is to try and find a good one of these on the Chinese websites. But I took the gamble and it did not pay off, because I ended up with another one of these completely worthless pieces of shit. And it's all been made in the same crappy way that the other one I had was. And these things are not even the right distance apart, and they're a little bit crooked again. So I got this one on eBay. They were hard to find in 57mm. So yeah, I don't know where I'm going to find. I may still be able to use this one. I don't know, but like I say, I'm not in any hurry to try and use this motor at the moment anyway. And the only other thing that came with it was this connection, which just has a couple of crimped connectors that go onto the power supply there, and the other end will go into the voltage regulator. So this was not part of the kit, and neither was this. So you could actually buy the spindle with this. I think on Banggood they had an option to do that too, but looking at the photos it looked like it was one of these shitty ones, so I opted to buy this separately and maybe hopefully get something better, but that didn't work out. This has something rattling around inside. Can you hear that? What the hell? I don't really want to power this up now. Looks like quite a nice power supply. You've got a digital readout for the output voltage, you've got a fan to cool down something or other, and you have a potentiometer on here where you can change the output voltage, and it also lets you connect this up. You can see the plug there. It came with this one, which lets you just sort of extend that potentiometer out from the box and put it somewhere further away where it's a little bit more convenient to reach, I guess. So that's nice, but the fact that there's something loose inside there is not nice. So I might actually have to open this up and just get rid of that rattling thing. Okay, I've figured out what the problem with that was. If you look at those two big power transistors or whatever those things are at the bottom, they're held up against the side of the case by a little metal bracket that's pulled in by that screw there. And on this side here, just by my thumb, there's another one. So that's also supposed to be held up against the side of the case with another little metal bracket, which is here. And it was just a little bit loose, so I don't know why it sounded like it was falling around in there, but it was just sort of loose enough that it was clacking around. So I think all it needs was to tighten that up so that it is actually pressing that transistor up against the side. So it starts off at about 0.1. Doesn't look like this readout goes to 0. Okay, it does. So from 0 all the way up to 48, almost 49 volts. So that's going to be just right for this motor. And it is a 400 and something watt power supply. The motor is a 400 watt motor, so it should be capable of handling the power that the motor can draw. So let's fire this up and see how it sounds. I'll put it on to about 30 volts maybe to start with. We've got a flashing light there for some reason. That says run/alarm. So 33 volts, and then switch on. And then this one we can... Oh, there we go. It's fairly quiet. That other brushed spindle was fairly quiet already, but I think this one is a little bit quieter. I mean, it should be because it doesn't have the brushes going zzz around inside this part here, but it's not super quiet. Oh, this is not full speed either, because let me just see how I can put that up to 49 volts, and then there we go, that's full speed. Yes. I can't feel any vibrations at all. It's quite good. Mind you, it is in this big vise, but still. Oh, it's... I can hear a little bit of vibration, but I can't feel anything. I think it's really nicely balanced. Yeah, it's nice. So you can change the speed by the voltage on here and by the speed control here. And if we switch it off, oh, it stops quite quickly. I wonder if it's I wonder if it has a brake. That's interesting. I wonder if what happens when you switch it straight back on? Okay. I wonder if it's going to slow down as quickly if I turn the power off at the mains. Seems about the same. So maybe it doesn't break. Maybe it's just that the magnets in here are able to sort of affect the rotor a little bit better, and maybe they're just stronger and they pull it to a stop quicker and it's not actually braking. Now I wonder what happens when I switch the mains on. Everything's on full speed at the moment, and it should be safe to just switch it on all in one go. Let's try that. Okay. Well, I probably wouldn't... probably wouldn't do that too often in actual usage, but it's good to know that it's not going to do anything strange. So yeah, I'm quite happy with that. It's a pity that I probably won't be using it for a little bit, but to be honest, I have seen some things on Banggood that have given me ideas about maybe building another CNC machine sometime. You can buy a fully built up linear axis that looks actually quite decent with a stepper motor and a nice ball screw and stuff like that. So who knows, this might actually find its way onto my CNC machine Mark II. So regarding how the carbon fibre cutting is going, I feel like I should make a little report on this, because at the end of the last video I'd only used it for about an hour, and at that point everything seemed okay, but you don't really come across all the problems in just a single hour of usage. So I have managed to cut a full quadcopter frame from this now. This is 3mm carbon here, and I had also 1.5mm, which is what I was doing in my last video. So those are the only two thicknesses I've cut, but the thickness doesn't really matter a whole lot because you just step down in increments anyway. But just to go over the issues that I have had, there's nothing really major, no showstoppers, but just a few small inconveniences. The first one that comes to mind is that this water bath drain gets blocked up fairly easily. Maybe once every hour or so it'll block itself up. It took me about 10 hours to do all the cutting for this frame, so that gives you an idea of how many blockages we're talking through that job. Not too bad, but the annoying thing is here that I have to pull this hose off and blow down it to get whatever's blocked in that direction, and then sometimes this little hole between the inside of the table and the outside gets blocked as well. So to unblock that, I put just a little bit of a tube on there and I blow in the other way. And sometimes it's not enough, you've got to do it a couple of times before it unblocks itself, but then everything comes right and it flows out again. And I've experimented with the flow volume, so I've turned this tap on to full and had it coming out basically as fast as it would go, and I also tried just leaving it on just a little trickle so that it's just enough to wet this area. And the slow trickle is nice in that when it blocks up, it takes a long time to spread across the table. So if I'm down the other end of the house doing something else, I only need to come in and look at it maybe every 10 minutes or so at the most. And when it's going fast, I have to come in and make sure it's not blocked up, because it's going to fill the table up quicker. But the positive side about the fast flow is that it actually seems to help to get stuff to go down at this side, because there's a little bit more flow being pulled down the pipe through gravity or something like that. Anyway, so it's not something that's really annoying me enough that I'm going to bother to do anything about it immediately, but it's a pretty easy fix to do. I think I could just cut into this wall and make a larger pipe going out, and that should probably fix it. But yeah, so that's the first thing. Other problems I've had have been the MDF has been fine. Actually, let me just mention that first. You'd think it would swell up, but it seems to take a long time to swell, and I try and do the cuts as quickly as I can once I get it wet, just in case it does swell up. But here's that first piece that I was using for quite a while, and there's not really any discernible swelling on it. The water does go all the way underneath, I found out, so the entire bottom of this was wet at one point, but that doesn't really seem to be an issue either. But the issue that I did have was getting the carbon to stick down to the MDF properly, and you have to make sure that everything is completely dry before you stick the double-sided tape on. So I've switched from using screws to bolt it down to double-sided tape, which is a lot easier, and means that I don't actually need such a thick piece of MDF. Actually, the reason I had a thick piece like this was so that I could put screws into it and have the screws would have something to thread into. But anyway, the problem with using double-sided tape is that you've got to keep it really dry when you stick it on. So when I pulled the first piece of carbon off of this, I didn't want to stick it on straight away, so I let it dry for a good day or so, and then I sanded it down so it was nice and smooth. Vacuumed off the dust so that the tape wasn't just sticking to the dust. And I thought, great, I'll just use that again. But the problem is, because we've got little grooves here, even after you've stuck the new piece on, the water can seep under through these grooves, and it gets all the way under and then starts leaking out from the sides of the groove, and after a while you'll find that the stickiness loses its stickiness. And you can see I've actually tried to cut one of the arms of the quad here, and that first one worked out, but the second one, which is the one that's sort of half cut here, that one did not work out, and you can see it's started to slip there. And what happened there was that the water just got all underneath the carbon, and the whole thing just slipped across, and it wouldn't push through. So to get around that, I've basically just been using a brand new, or well, you can see there's something's been cut into this one already, but an almost brand new piece of MDF every time, and that has been working quite nicely. And this problem of getting or not being able to cut through because it moves is made worse by the fact that the bits seem to get blunt rather quicker than I had hoped for. And admittedly, I am using pretty cheap stuff. This is the ones I'm using. These are, I think it's about $7 or $8 for 10, I think. Yeah, from Banggood. And these are, there's a couple of types I tried. One is it's got a kind of a yellow goldy coating on it, and the other one's pretty much the same except there's no goldy coating. And I haven't not noticed really much difference between them, although if I had to pick one, I'd say that the yellow ones probably last a little bit longer. But from one of those, these are the 2mm diameter that I've been using, one of those let me cut all of these pieces and then this one, and then when it was cutting this one it broke partway through. And I think it broke because the carbon was still fully stuck down properly, but the bit was getting too blunt and it just couldn't cut, and it was just being pushed instead of cutting. So I swapped the bit over and was able to continue cutting, because now that my Bluetooth system is working properly and I don't lose the position, I can just pause the job and then continue, which is much nicer than having to try and reset everything again. So that's how much I got from that first bit. That was 1.5mm carbon there. And then when it came to doing these arms for 3mm carbon, let's see, what did I do? I think I did one with a brand new bit here. Oh yeah, I did 1, 2, 3, and I managed to finish this one, but it looks a bit shabby, and I'll show you later on how it turned out. It's usable, but it could be better. And at that point I changed the bit again, so I'm on my third bit now, and this was the third bit that cut this one, and it did a very, very nice job. So there is quite a difference between bits when you change them over. It's very noticeable. And you may have noticed that there's another piece in the middle here that's been skipped over in the same way as this one did. But if you look there, I did actually try and cut something. So this is where I was pushing this bit to the limit to see where it would break, but unfortunately it didn't quite. Actually, there's another annoyance with this carbon, is that you can't really see anything very well until you put a light on it, because it's all black. Even when I'm not showing it to the camera, I quite often use this little light to look at it. We can't really see it too well there, but those holes are not lined up in the positions that they should be properly, and the hole at the top there is in the wrong place, and it's all just a little bit off. So when you're getting to the end of the life of one of these bits, you really have to keep an eye on it, because even if it cuts through, which it has been doing still, the holes are filled up with dust, but they did actually cut all the way through. But even if it cuts all the way through, it's not giving you the proper accuracy and stuff. So that's something you have to keep an eye on. And if in doubt, change the bit, I guess. So that's what I've been doing after I saw this kind of problem showing up. And this one just to the left of it, which I'll show you in a minute, the holes are all in the right position, but they're a little bit too small,
because I guess the edges of the bit were starting to wear down, and it wasn't the full 2mm diameter that it was supposed to be.
So here are the parts that I was making there, and as I mentioned before, the arms are 3mm and the rest of it is 1.5mm. And the quality or the finish on the edges is pretty much directly related to how fresh the end mill was when I was doing the cut. The top plate and the bottom plate there both took about 2 hours each, I think, and the arms took about an hour and a quarter each, so that's 9 hours, and then these little bits were about 20 minutes each. These were the ones that I made in the last video. So we're talking about 10 hours of actual cutting time, but it took me a fair bit longer than that because of the screw-ups that I just showed you before. So it was actually probably about 12 hours or so of time that the machine was running, and it did not drop out even once. As I mentioned before, the Bluetooth is working really, really well, so I'm really happy about that, to get that problem fixed. Anyway, so I don't know how well we're going to be able to see this. It's kind of hard to... These two bits, this was the first one that I cut, or when the bit was still fairly nice, so I don't think I'd really bother sanding or finishing this off anymore. If I was to hand this to somebody to have a look at, I would probably feel obliged to say, be careful of the edges, are a bit sharp. But when I'm handling it myself, I don't feel too worried. Like, I'll just be a little bit careful, but it's not bothering me enough that I would bother to sort of go around and sandpaper the whole thing to smooth them off. And as it happens, the bottom piece is pretty much the same as well. This bit here, normally, so there's a plate right on the bottom. Normally I would make this to go all the way around like that, but I was running out of the 1.5mm sheet, so this is the only size I could manage. So I redesigned it to just cover the innermost screw on there. I think it should be alright though. It still gives a nice solid base for this arm. So the arms are ranging in quality from very nice to a little bit scary. So I'll show you the very nice one here first. This was done with probably the newest of the bits, like a brand new fresh bit, and it's about as good as I could hope for, really. It's actually quite nice. But you may be able to see just a slight bit of roughness there. Oh yeah, that is actually a little bit rough, so I would probably want to sandpaper that off or file it down a little bit. But the rest of it is quite nice. And this being done with the new bit, all the holes are the right size, so the 3mm screw fits through there quite nicely, no problems. This is the only one that I managed to get where the screws just fit in right from the beginning. So let's have a look at the other ones. I think they're sort of varying in from better to worse. So this last one was where the bit was on its last legs, and this one here looks pretty much the same, except that these holes, when you actually try and put a screw through, you could probably hit that with a hammer to get it through. That's what I did with a couple of the other pieces where the holes were not quite big enough. I just used the screw as a file to like slam it through and get it to the right size. So that's what I'd probably do with this one. Oh, if I push it, actually, that's not too bad. Actually, that's probably just usable as is. But the next two are definitely, you're not going to be able to do that. So these holes, the bit has just become, the diameter has changed to the point where I can't even get that even halfway through that hole. So for this, I'm going to have to put this on my drill press and drill it to 3mm like it should be. But the nice thing is that these holes are already in the right place, so it's going to be really easy to do that. And yeah, it's a totally usable piece. I'm just sort of being a little bit nitpicky about how it turned out because I'm trying to get things as good as they can. Now this one here, I took this off and I just carefully handled it so that I could keep it in this condition to show you, because this is probably what people are sort of going to be wondering about, how did it turn out quality wise. So this is where the bit was still able to cut through, and it has still put all the holes in the right place. At least I bloody hope it has. It looks alright, but they're definitely not going to be I can't even really get the tip of the screw in there, so that's not going to work straight away. And you can see that the fibers, at least I think those little white things there are the fibers that have been pushed in rather than cut through properly. There's quite a few down here. It's funny, they're actually white. Look at that, they're like little shards of glass or something. Yeah, one time it was cutting and the water was not quite covering the part where the dust was coming out, just for a moment, before I managed to put the water onto it. But this stuff was actually white when it's released, or when it's pulled out of its resin. Or maybe it's just white when it gets thinned out like that. But anyway, this piece is, again, still usable once I drill out these holes to the proper diameter. But you've got to be careful when you're picking it up, at least until you've cleaned it up a bit. So this one's definitely going to be getting a bit of sandpapering or filing down before it gets used. I could, of course, just rub it off with a tissue, even maybe it looks quite soft. But I just thought I'd leave it like this to let you have a look at it. So it's easier to show you a picture than try and explain what I was seeing. Back is not so bad. So there we have it, a completely homemade quadcopter frame with a pretty much completely homemade CNC machine. I'm quite pleased with this outcome. To be honest, I didn't really think that I would get to this point. I would have been happy just to be able to cut plywood, but to get to here is it's really great. I'm very pleased. Oh, wait a minute. One more thing. I made a spreadsheet to total up the costs of everything that I've spent on this project, because I get asked that quite frequently, and I didn't really bother to do this originally because, to be honest, I don't know if I could really recommend doing things the way I've done it. Although from what you just saw, you might be thinking, well, this is a good idea. Well, why shouldn't we do that? It was a hell of a lot of effort to put it all together, and I think I just got kind of lucky that it worked as well as it did. At least with the tools I have. I had a pretty basic drill press, and I didn't really have a whole lot of sophisticated measuring devices, just a steel ruler and stuff like that. So yeah, I don't think I could really recommend doing this, and I would not do it again this way. So that's why I didn't really do this earlier. But here are the things that I bought, and a lot of it came from Banggood, and I spent about $350 there. This is US dollars. And then here in New Zealand, I spent about $378 or so on stuff locally. That comes to about that. So it's not too bad, actually. It's a little bit less than I thought it was. Just at a rough guess, I would have thought I'd spent a little bit more, but that's not including the plastic bucket and the garden hose sprinkler system stuff that I used for making it waterproof on the table part of the CNC. And it's also not including a bunch of tools that I had to get, like thread taps, and I actually bought that drill press to do this project, so I'm not including that kind of thing. And you do, of course, need a laptop computer to run it, and I was using LiPo batteries to power the stepper motors and stuff, so all that stuff I have not included, but the bulk of the costs are in this here, so I think you could do it for less than $1,000. And then software I spent, I'm not sure if this is exactly what I spent, these tend to change a little bit, but somewhere around €40 for QCAD. This is, you can use it free if you want to, but you sort of miss out on some of the good features. And I wanted to support this because QCAD is a really phenomenally, professionally well done piece of software. I really like using it. And Estelcam, I actually, if you look at Estelcam website now, they have a more recent version than the one I got, and they're charging $59. I'm pretty sure I only paid $40 for it, but I have a slightly older version, so maybe that's why it was cheaper. And then the gerbil is free. So hopefully this should answer questions about all this kind of stuff. So that's all I have for now. If I come up with some other observations that are worth mentioning after using this a little bit more long term, I'll maybe mention those in the future, and maybe try the spindle sometime. I don't know. Anyway, thanks for watching.